take a look at the last section, which is 3.5. And this is on finding roots again. But this time the roots might be complex numbers. We can still do synthetic division. We can still use rational root theorem. We can still use the graphing calculator. Everything we learned the last 2 days still works. But when you end up with the square root of a negative, we're not going to say no solution. Now we're going to write what that would be using I. Okay, so just a reminder, we've mentioned this several times, but if you have a root that or a 0, it means you can take that number, plug it into a formula, and when you plug it in, you get 0 as the answer. That also means it's where the graph crosses the x-axis. So when you're dealing with real answers, roots, zeros, x-intercepts all mean the same thing. When we're dealing with imaginary answers, this part is going to go away. You're no longer going to be able to look at a graph and figure out the imaginary answers. Okay, the only way to get those is quadratic form. Yes?
What does imaginary mean?
We're gonna talk about that right now. So if you draw a graph like this, it never crosses the x-axis. Everybody agree with that?
Yes.
Okay. Never crosses. It doesn't mean that it doesn't have roots. It just means that it has no numbers that are real roots. Let's look at this one. Y equals x squared plus 1. Let's set that equal to 0, try to solve it, and see what happens. First step would be to bring the 1 to the other side. And what would be your last step?
Square root both sides.
Square root both sides. So you have x equals the square root of negative 1. Now, let's try to do that on the calculator and see what happens. Second square root of negative 1. Well, okay. Let me put the calculator in algebra 1 mode. Like we've been doing our lessons so far, it's basically algebra 1 mode. And when we had a square root of a negative, we just said that there was no solution. Or we said there was no real solution. It's not saying that it can't do it. It's saying it can do it. Do you want an answer that's not a real number? Right? And that's what we're going to look at right now. Okay? So there is a way to represent this in math. There's a symbol for it. And that's what we're going to look at. Okay. So we've talked a little bit about I, okay, before, and did it probably last year in Algebra 2. And I is the symbol for the answer to this problem, square root of negative 1. Okay, it's kind of like when you write 3.14, when you write that, instead of writing that entire thing, we have a symbol for that, so we don't have to write that every time. It's short. You write pi. Well, same thing with this. Instead of having to write a square root, a negative symbol, and then a 1, the abbreviation we use in math for that whole thing is I. So I stands for the square root of negative 1. That's what it stands for. And you can do that on the graphing calculator. It will do it, as long as the calculator is in imaginary mode. Okay, so instead of real, now I put it in imaginary. And it doesn't give me an error anymore. It tells me what the square root of negative 1 is. It says that it is I. So if I did I squared would be I, which is square root of negative 1, to the second power. What would the square root of negative 1 squared come out to? Negative 1. Whenever you square a square root, they cancel, and you're left with what was underneath the square root. So I to the second power comes out to -1. So you should never leave I to the second power in your final answer. Always want to change I to the second power to the number -1. Let's try plugging in I in this and see what happens. So we've got x squared plus 1. Fill in I for x. I squared plus 1. What did we just say I squared is? -1. And what's -1 plus 1? 0. So when I plug I into the equation right here, I get 0. What does that mean about I? That it's a root. Yes. Anytime you plug something into an equation and you get 0, you just found a root. Maybe the root, maybe one of the roots. But in this case, when you plug I in, you get 0. That means I is a root. Now, when you graph this, you're never going to see it cross the x-axis. Here's the graph of x squared plus 1. Just because it doesn't cross the x-axis doesn't mean it doesn't have roots. We just found a root. It's I. But you can't see it on the graph. So that's why I'm going to show you how you figure that out with quadratic formula. Any question why I is a root here? Anything you plug in and get 0 for is a root. So when you write a complex number, a lot of times they look something like this, like 2 plus 3i, or 2/5 minus 1i. Those are complex numbers. But they have two parts to them. They have a real part, and they have an imaginary part. When you write a number in standard form, the real part of the number always comes first, and the imaginary part of the number always comes second. So these two that I just circled in red, they have both real parts and imaginary parts. This one that I just circled in blue, and this one, those are called pure imaginary numbers. They're pure imaginary numbers because they don't have a real part. All they have is an imaginary part. And the 4, the one I just circled in purple, that's just called a real number. So they're all complex. Everything is a complex number that we study. It's just sometimes a complex number has just a real part, just an imaginary part, or both a real and an imaginary. Okay. Any questions on that? Okay, but that is the pattern you want to write a complex number in. Real part there. Technically, this could be a plus or a minus. Imaginary part, and then an I. That's how it should always look in standard form. If one of these parts is 0, you don't have to write 0. You can leave that off if it's 0, like in the first 3. Okay, so first thing to understand in this lesson is I is not a variable. I know a lot of times we use letters to represent variables, but in this section, I represents the square root of -1. That is a number. Just like in math, that is a number, pi. In the Greek alphabet, yes, they use it as a letter, but we would never use this as a variable in math, never. Okay, we do use certain Greek letters as variables. That's not one of them. because that stands for 3.14. So, same idea with I. It stands for the square root of -1. It is a letter in the English alphabet, but we're not using it as a variable. But if you kind of think of it like a variable, you can use the rules you already know for combining like terms. Right? Like 2x plus 3x. That's 2 times a variable plus 3 times a variable. X is a variable. What would you get when you simplify that?
5x.
5 times your variable. You can do the same thing with numbers. If you have 2 times the number I plus 3 times the number I, that is 5 times the number I. Even though I is not a variable there, the idea still works. Okay, when we multiply complex numbers, we're going to have to use double distributive property, or FOIL. That's going to result in I squared coming up a lot. Always change your I squared to -1. When we do a division problem with complex numbers, you're not allowed to leave I in the bottom of a fraction. So I'm going to show you a way to get rid of the I in the bottom with what's called a conjugate. So we'll do one of those. And the last thing is, when you are taking the square root of a negative, how do we do it? When I write square root -x, what number is in front of the x? Even though it's not written. Yeah? -1. So you could think of it as that. Square root of -1 times x. When you have a product under a square root, you can separate it into 2 square roots just like that. Square root of -1, square root of x. And this part is going to simplify. What did we just say the square root of -1 is? What's the symbol? Yeah, I square root x. So it's a little weird. I know we put the I in front, but the reason we put the I in front is because if you do this, that's confusing to me. When you put the I after something that has a square root, I can't tell if the I is under the root or not under the root. It's kind of hard to tell. So the easy way around that is when you have a square root, we just put the I in front, and then there's no confusion. Now, if you don't have a square root, let's say you had this, it's perfectly fine to put the I at the end in that case, because there's no square root there. So I'm not confused if this is under a square root or not, because there isn't one. So this is the only time you put the I in front. You have the square root. Want to avoid that. So let's look at these two. If you notice the pattern, okay, when you take the square root of a negative number, it's basically just the square root of your number with an I in the front. That's what happens when you take the square root of a negative. So what would be the square root of -4? Yeah?
I times the square root of 4.
I times the square root of 4, and the square root of 4 would be 2. So we can simplify, I mean, that's not wrong, that's just not done yet. I times 2, I would just write that one as 2i. How about the square root of -7? How would we write that one? Yeah?
I times the square root of 7.
Yeah, and you can't break down the square root of 7, so we're going to leave that one just like that. How about the square root of -9?
Yeah. 3i.
Yeah, that's I times the square root of 9, but the square root of 9 comes out to 3. 3i. And what about the square root of -20? You do it just like you would square root of 20, so you do have to break that down, but it's going to have an I in it. Yeah.
5i square root of 20?
So how did you break down, let's start with, if you just had square root of 20, how would you break that up into two square roots?
I did square root of 10 minus square root of 2.
Okay, could you break it up into two numbers where one of them you can take the square root of in your head?
The square root of 4 times the square root of
Okay, and what's the square root of 4? So 2 square root of 5. So that's the square root of 20. What do we think negative 20 is going to be? Yeah?
Would it be 2i times the square root of 5?
Yep. 2i square root of 5. Okay. Any question on that? Okay, so that's taking a square root. That's going to come up in the quadratic formula when you do the square root of b squared minus 4ac. Probably going to end up with a square root of a negative in some problems. And that's how you handle it. Okay, let's do an addition problem. So addition problem is like combining like terms. You can combine real with real, and you can combine imaginary with imaginary. And the way you're combining them this time is addition. If we add these together, what would be the real part in my final answer? If you take each real part and add them together. Yep. So we get 11 plus what would be the imaginary part? Yep.
2i.
2i. It's negative 3i plus 5i. So that's adding complex numbers. Let's look at subtracting. Yeah.
Does it kind of work like a variable?
Kind of like you can use the same kind of thinking, but just remember I is a number.
Alright, yeah.
It's like square root of negative 1.
Placeholder?
It's like, yeah, it's like a symbol for the square root of negative 1.
Alright.
Yep. It's not a variable. All right, now this one, same idea, except think of the negative as being distributed. So it's 4 minus 2i minus 6 minus I. What would you get for a real part when you do this one?
Negative 2 minus I.
Negative 2, that's the real part. And what about the imaginary part? Negative 3i. Negative 2i minus I is negative 3i. So it's exactly the same thing if you had 4 minus 2x minus 6 plus x. You do it the same way. Same kind of thing.
And if you get 1i, you just write I, right?
If you have 1i, you could just write I. Yep. Okay, let's look at multiplying. I know this one's multiplying because they didn't put an add or a subtract between the parentheses. Okay, so to multiply, I need to FOIL it out. 2 times 5 is going to give me 10. What about 2 times negative I? Negative 2i. What about 5 times 3i? Yep. 15i. So I'm just doing this off to the side. What's negative 2i plus 15i? 13i. Now the last part, let's be careful. First, it's a positive times a negative. A positive times a negative is a negative. So I got my negative. What's 3i times I? I already took care of the negative.
I squared.
Yeah.
I squared.
3i times I times I is I squared. But this is 3i times I. Yep.
Negative 3i?
Negative,
Oh.
negative what?
It's just straight up.
Negative 3i squared. It's the same thing as doing 3x times negative x. That would be negative 3x squared. Now, let's look at that. We have an I squared. I squared is what number?
Negative 1.
Negative 1. So it's really 3 or negative 3 times negative 1. What's negative 3 times negative 1?
Positive.
That's a positive 3. Negative 3 times negative 1. And when you combine like terms, what do you get for a real part? 13. Just a coincidence, it's 13 for real and imaginary. That does not have to happen. But that's how we multiply those two. Any question before we look at division? So the point of this is really to be finding roots. This is not the focus of the lesson. Right? This is just a quick review of complex numbers. What I want to be doing is this, find the roots. And when we find the roots, we might get negative numbers, and I'm just kind of reminding us how we have to work with it. Okay, so the last thing we need to look at is division. The only problem with division is you're not allowed to leave an I in the bottom. So the way that you can get rid of the I in the bottom is to use what's called a conjugate. So a conjugate, very simple idea, is when you have an imaginary number, you change the sign of the imaginary part. Could you just sign up? Thanks. Yeah, just sign up. Then I'll remember you left. Otherwise, a month from now, I'll be like, where was he? So a minus bi would be the conjugate of a plus bi. Change the sign of the imaginary part. Don't do anything to the real part. Keep it the same. Okay, so what would be the conjugate of 3 plus 2i? Yeah.
3 minus 2i?
Yep. So we're not doing anything with it, we're just practicing finding it. And then we'll do something with it in the next step. How about 4 minus 5i? What would be the conjugate there? Okay.
4 plus 5i.
4 plus 5i. And the conjugate of 3i? Yep, yeah. Negative 3i. And the conjugate of 6? 6 stays the same. Think of it as 6 plus 0i. The conjugate is 6 minus 0i. That's still 6. Okay, so any question on how to find a conjugate once you have a number? Yes?
So it's almost like absolute value, but just for imaginary numbers?
Well, I mean, you can end up with a negative part. Sometimes that's imaginary, or sometimes it's a positive.
So like the opposite.
It's the opposite.
Okay.
Yeah.
So you just flip the signs if it's a positive or negative, and if it's a regular number, you don't change anything. Basically.
That's what ends up happening because you are changing something. You're just changing that to that,
Okay.
which is still the same thing. Yep. Okay. So now let's do a division problem. In order to do a division problem, you don't actually do division, you do multiplication. And what we do is we multiply the top and the bottom by the conjugate of what's in the bottom. Okay. So what's the conjugate of what's in the bottom here? Yeah,
2 plus 3i.
2 plus 3i. So multiply the top and the bottom by 2 plus 3i. And we'll do that out and then watch what happens in the bottom. Okay. So 5 times 2 gives me 10. What's 5 times 3i?
15i.
15i. What's 2 times I?
2i.
And if we combine like terms, what's 15i plus 2i? 17i. And the last part, positive I times positive 3i. That's a positive, yep, 3i squared.
Which is negative 3.
Okay, and yep, we'll come back to that in a second. Now let's do the bottom. 2 times 2,
4.
4. 2 times 3i,
6i.
6i. 2 times negative 3i. Though that always happens. Right? Whenever you multiply conjugates, those two are going to cancel each other out. And now we have negative 3i times 3i. What's that? Yeah.
Negative 9i squared.
Yep. And now, everywhere we have an I squared, we have to change that to negative 1. So we have 10 plus 17i. This is negative 1. What's 3 times negative 1? Negative 3. Okay. And we have 4 minus, this is also negative 1. What's 9 times negative 1? Negative 9. I still have that other negative that was there before. Okay. 10 minus 3 gives me 7 plus 17i. Divided by, what's 4 minus minus 9? 13. Are there any i's left in the bottom? That's why we multiplied by the conjugate. Makes all the i's disappear. But you should write that answer in standard form, which means writing it as 7/13. That's the real part. And 17/13. That's the imaginary part.
Is that how you want us to do our answers?
Yeah, so your answers should always look like what's in this purple box. Real part, plus or minus, and then the imaginary part with the I. Yep. It's not a big step to really go from this to that. You just take each number in the numerator and put them over the denominator separately rather than together. Yes?
And if it was negative 17i, would you just do it minus 17?
Yeah, if that was a negative 17, then that would be a minus right there. Yep. And the I, they just put right next to the whole fraction, because this is the imaginary number, 17/13.
Does it matter if it's 17/13 I plus 7/13?
No, you could technically put the I in front, but really the only time we do that is when you have the square root. Any other time, you put the I after the number. Yes?
So if those numbers are positive and you could reduce them, would you reduce them?
If you could reduce that, yeah. So like if that came out to 7/14 instead of 7/13, yes, I would have reduced that.
Even if there's even if you have to put the I next to it. So like let's say it was 7/14 I.
Yeah, you can
So-
reduce that to 1/2 I.
Alright.
Yep. So you always reduce your fraction as much as you can, but 13's prime, so we can't reduce that. And 17's also a prime. All right, so now let's try to find the roots. Okay, what kind of polynomial is that one? Based on the highest exponent. Yeah?
Quadratic.
It's a quadratic. Can we just plug that into quadratic formula, get our answers, and be done? Yes, we can. It's quadratic. We don't have to do anything with rational root theorem or synthetic division. What's A going to be? 1. And B? 1. And C? 1. Yeah, they're all 1. So we get negative B plus or minus square root of B squared. And what comes after that? 4AC all over 2A. So that's going to be -1 plus or minus. What's 1 minus 4 times 1 times 1? -3 over 2. Now, we're not going to say no real answers, because they didn't say to find the real answers. They said find the zeros. That means find any zero you can. What is the square root of -3? How do we write that? Yep. I root 3. So those are your roots. -1 plus or minus I root 3 over 2.
That's it.
That's it. Yep.
And you would simplify if it could simplify.
Yeah, you could, I mean, they didn't say to write the answer in standard form here, but if you wanted to write it the way I've been writing it in standard form, it's -1/2 plus or minus root 3 over 2 I. That's standard form. Put the -1 over the 2, put the root 3 over the 2, and I guess this is kind of an exception. I said we always put the I before the square root. Well, I can tell here that the I is not under the square root because it's a fraction, and you've put the I in the middle. To me, that's very obvious the I is not under the square root. So that is another case where it's okay to put the I to the right. That's perfectly fine.
Would it be correct if you put it on the left?
If you put it on the left, it would be okay. But yeah, generally we'll put it on the right. All right. Any questions on that? And that's it. That's your answer. Now, notice the two answers that you got here. These two answers. -1/2 plus root 3 over 2I. -1/2 minus root 3 over 2I. What's the connection between those two numbers? They are what?
They both have a denominator of 2.
Well, it's -1/2 plus root 3 over 2I, -1/2 minus root 3 over 2I. There's a name for those pair of numbers. They're what? Well, they are the roots. It's like 5 plus I, 5 minus I.
A conjugate?
They are conjugates, right? These are conjugates. And anytime that you are solving a problem that is going to have I in the answer, you always get a pair of answers. You never get one single answer with I. You could have 2, you could have 4, but they come in pairs. Specifically, conjugate pairs. So if you're solving a problem and you find that 3 plus 2I is an answer, then 3 minus 2I is automatically the answer. So roots that have I always come in pairs. If 8 plus I was an answer, then what else would be an answer? 8 minus I has to automatically be an answer. Always. And that only applies to complex numbers with I. Okay, so all the theorems that we've done so far, remainder theorem, factor theorem, they all work with synthetic division. They all work with complex numbers. There's no difference with any of the theorems we learned to use with complex numbers. They all work the same. We didn't really do factor theorem, so you don't have to write factor theorem down. But we did remainder theorem, synthetic division. That's the two we did yesterday. So now we're just going to try a couple problems finding some more roots, just like the first one. But I'm not going to do that one. Okay. Let's look at this one. Find all zeros of x cubed minus 1. Doesn't say find the reals. It says find them all. So If it did just say find reals, then you can ignore everything we learned today. You don't have to do anything with imaginary. But it says all. Okay, what kind of equation is that? It's a cubic. Can we just plug into quadratic formula, get the two answers, and we're done? No. It's a cubic. We got to get it down to a quadratic before we can do that. Well, we need to figure out a list of possible numbers that could work. What's the name of the theorem we can use that would give us a list of possible roots? Yeah?
Rational root theorem.
Rational root theorem. Okay, if we can't find a rational root, we're going to be stuck with a cubic. That's not good. Okay, so we gotta find one. What would be the factors of my constant, -1? Yep,
Plus or minus 1.
plus or minus 1. And what would be the factors of q, the leading coefficient? It's also plus or minus 1. So now when you do all the p's over all the q's, what are all the different combinations you could have?
Plus or minus 1 over 1.
Just plus or minus 1 over 1, which is just 1. Now, at this point, I would normally graph that, use the calculator to narrow down this list and cross out the ones that don't work. There's so few numbers here, and that's such a simple formula, I can plug the numbers in faster than I can graph. So if I plug in 1 for x, is 1 a root? How come?
Because x cubed, or 1 cubed is 1, and then 1 minus 1 is 0.
Right, if you plug in 1, you get 0. If this was a really long formula and it had fractions in it, high powers, and I wasn't plugging in a 1, like even if I had to plug like a 7 in for this, I can't do as much of that in my head. Okay, it's easy. But I'm only plugging in a 1, and it's just x cubed minus 1. So it's faster to just do it in your head. So 1 is definitely a root. So we can start making a list. That's one of the roots. Now, what do we do with the 1 to turn the cubic into a quadratic? Yeah.
Divide by x.
So we're gonna, what kind of division are we gonna do? Synthetic, right? We're gonna do synthetic division. And what are we gonna divide that by to get our other factor? What's the factor we're going to divide x cubed minus 1 by?
It would be 1.
Well, 1 is the root, but the factor would be...
I thought a root was a factor.
No, a factor has to have a variable, a plus or
Oh.
a minus, and then a number. Yep.
Would it be -1?
X minus 1.
Variable, plus or minus, and then a number.
X minus 1.
X minus 1. So we're going to divide this by x minus 1. If you want to do it with long division, you need to do this. If you want to do it with synthetic division, which is faster, you can put the 1 on the outside, fill in zeros for what you're missing, and see what we get. Okay, so bring down the 1. 1 times 1 is 1. Add that up, we get 1. 1 times 1, 1. 1 times 1, 0. So we already knew we were going to get 0, but we just double proved that 1 is a root. Now, what do I do with that to get my other two roots? Yeah?
Do you have to find a quotient from that?
Okay, I've got the quotient.
You can either, if you can't factor, you can put it into quadratic because you have to put the x squared plus x plus 1.
Plus 1. So now, you're looking at the other factor. That's the other factor when you try to factor x cubed minus 1. You already divided out the x minus 1 factor. Now, look at this factor. We have to set that equal to 0 and solve it. How do we solve this? X squared plus x plus 1. Quadratic what?
Formula.
Yeah, quadratic formula. and x squared plus x plus 1, we've already done that problem right here. So now you would go through what we just did here to get your other roots. Negative 1/2 plus or minus root 3 over 2 I. Those are your other two roots. Okay, so once you get it down to a quadratic, then you just use the quadratic formula, but you've got to use synthetic division first to get it to a quadratic. And you should always have as many roots as the highest exponent. So if you're doing a cubic, you should have 3 roots. You can't say they're always going to be distinct. You could get a repeated one. Right? That can happen. But in this, they are all distinct. If I graph this, how many times would it cross the x-axis? 3? Nope. If it crossed 3 times, that would mean there's 3 real roots. And it definitely does not have 3 real roots.
So is that second one not 2 different roots because it's a plus or minus?
Yeah, this is 2 different roots. There's 3 roots right here.
But is it because it's an imaginary number, it doesn't cross?
If it has an imaginary number, it will not cross
So
the
this
x-axis.
only crosses once.
This will only cross the x-axis once. So if you graph this and you do second calc 0, you will get this answer. But there is no way to look at the graph and get these other 2. They're not visible. Got to use quadratic form. So if you look at the problem we did here, we had a 3 as the highest exponent. We got 3 roots. Here we had a 2 as the highest exponent, and we got 2 roots. That's always going to be true. The number of roots is always going to equal the degree of the polynomial. And in general, I'm probably going to have you solve cubic is probably the highest, so 3 answers. And if we know that the number of roots equals the highest exponent, then the number of factors also equals the highest exponent. That's what this says. Because you always have as many factors as you do roots. If 2 is a root and 5 is a root, then you know x minus 2 is a factor and x minus 5 is a factor. So you always have the same number of factors as you do roots, and you always have as many roots as the highest exponent. Those things all go together. So if you were doing a cubic problem, how many roots would this problem have? Yeah, 3. How many factors would it have? 3. Whatever the degree of the polynomial is, if it's degree 3, then it's going to have 3 factors. And those would be the factors of that. At this point, you should be able to figure these out. The way you would have to figure them out is rational root theorem. P could be plus or minus 1, 2, 3, or 6. And then you'd have to graph it to narrow that list down. And you'd see that all your answers are actually nice numbers. -1, -2, +3. Those are all numbers that you would have gotten from rational root theorem. Okay. What about if you had a 5th degree polynomial? How many factors would that have if you wrote them all out? Yeah?
5.
It would have 5, but I'm not saying they can't repeat. They definitely could repeat. And that's a 5th degree polynomial if you multiplied it all out. But it only has 2 answers. -1, +2. But technically it's -1, -1, +2, +2, +2. It is 5 answers. It's just there are repeats. So repeats are allowed. last question. It's kind of like one we did yesterday. If I told you that I had a problem with roots of 2 and -3, what would be the factor that 2 came from? Yep.
X minus 2.
It's x minus whatever I told you the root was. How about -3? What would be the factor that comes from? Yep.
X plus 3.
X minus whatever I told you the root was, which in this case would be x plus 3. So now I want to do the same thing, but with imaginary. All right, so let's say I had roots of 2 plus I, and what else do you know has to be a root if 2 plus I is a root?
2 minus I.
You know 2 minus I has to go with it. If 2 plus I is a root, the format of your answer is always x minus the root. That's how you write the factor. So this one would be x minus, there's my root, 2 plus I. That's the first factor. And what would the second factor be?
X minus 2 minus I.
Yep, x minus the root. Once we write that, now we just have to clean it up. What would we do with this negative in front of the parentheses? Yep, distribute it. Same thing with this negative. X minus 2 plus I. And now we just have to distribute these two things together, and we'll have our final answer. What's x times x? X squared. What's x times -2?
Negative minus 2.
Minus 2x. X times I.
X
xi, or just ix, however you write it. What's -2 times x?
Negative 2x.
-2 times -2?
4.
Positive 4. And -2 times I?
Negative 2I.
-2i. And the last one. What's -I times x?
Negative I.
-ix. And a lot of this is going to cancel, you'll see. What's -I times -2?
Plus 2I.
Plus 2i. And what's -I times positive I?
Negative I squared.
-I squared, which means -1. So, plus 1. What cancels out there?
All like half of it.
Yep. You should never be left with anything with an I. So the ix is gone. -ix is gone. What else? 2i. And
Negative 2i.
-2i. Are there any i's left? So you're left with x squared minus how many x's? Minus 4x
Plus 5.
plus 5. That's how you find a polynomial that has imaginary roots. It's the same way you do it as real roots. Okay, so reminder that for tonight, okay, that's the take home. So the test will open at 2:40 today. It'll close at 9 a.m. tomorrow morning, Eastern time. It'll be on pair assessment. There will be a time limit of 2 hours. You normally have 1 hour. It's a double the time. If it's late, it'll be a 0. Make sure you upload your work with the problem. Did anybody have trouble using their camera to upload the work? If you don't have any work, then it will be worth half credit.
I just have a question. If I'm taking it tomorrow in class and I don't do it online, will it still count as a 0 or you have to switch it?
That's it. Okay, so anyone else that's not doing it as a take home? Okay, just one. Okay, if you can't, let me know now, and now you can do it in class. You don't have to do it as a take home.
I'll do the best I can with taking a photo. Like, I have the worst Chrome book ever.
Okay.
So I can, like, try to really get it as good as possible.
Yeah.
Well, I said there's somebody here in class.